Yo, what's up, everybody? I've been practicing talking to this computer, trying to get better with it. I promise this week the videos are going to be a little bit better. Hope you're all safe, happy, well. And we're going to talk a little bit about solving by substitution again. Having done this for years, I realize people struggle with this a little bit. So, what we're going to do is do it again. It'll either be posted up at the end of the week for people who are struggling, or it'll be on next week. So, depending when you get the link for this, that's when it'll happen. But I thought I'd be a little proactive and go ahead and do this. So, if you're ready, I cut my hair, made sure I'm ready to go for this. So, let's go ahead and let's jump in. So, systems, don't forget, when we're solving system of linear equations is two equations working together. We solve them by graphing because it gives a very good pictorial description of what's going on. When we're graphing a line, we are showing all of those solutions. There's an infinite combination of x, y's that make that sucker work. So if we have two equations, there's an infinite amount of solutions that make one work. There's an infinite amount of solutions that make the other one work. We're looking for that point where they both work. Now keep in mind, there's three possibilities. Possibility number one, they cross, they intersect, they share a point, they have one solution. They could be the same line. That means they have an infinite amount of solutions on those lines. Or they're parallel, never cross, they don't share a point, they have no solution. So, without further ado, let's do some more by substitution. So, first example we're going to do, we have y equals 4x plus 8. We have y equals negative 2x plus 26. So, again, it's a good idea to keep in mind what we have going on. We have two lines. We have an infinite amount of solutions for each line. We're looking for that one point that they share. That means at that point, they have the exact same x and the exact same y value. So we use that to our advantage. So the first thing we're going to do, we're going to say, all right, so this y equals this 4x plus 8. And that marker's about dying. We know that this y equals that negative 2x plus 26. What we're doing is we're looking for that point that they share. So at that point, this y and this y have the exact same value. So if this y equals 4x plus 8 and this y equals negative 2x plus 26, and we want them when they're equal, let's set them equal. So we're going to put that 4x plus 8, set it equal to negative 2x plus 26. We're substituting that 4x plus 8 in for that y, or that negative 2x plus 26 in for that. Either way, they're equal. Now we have a equation that we can solve very easily. Variables on both sides. Choose the side with the least amount. Negative 2x is obviously smaller, so we are going to add 2x to both sides. That's going to give us 6x plus 8 equals, our x's cancel out on the right-hand side, that equals 26. At this point, we are going to subtract 8 from both sides. That's going to give us 6x equals, 8's cancel out. 26 minus 8, of course, is 18. Divide both sides by 6, x equals 3. So since we have the x value that makes those two true, we now can find the y value by plugging it into one of those. Choose whichever one you think's easier. I have a feeling most of us would probably choose that y equals 4x plus 8. So we have y equals 4x plus 8. We're going to go ahead and substitute that 3 in for x. And then we're going to solve. That one's pretty easy. 4 times 3 is 12, and 12 plus 8 is 20. So my point of intersection for those two lines is 3, 20. That, of course, is a coordinate, and we'll put that in our solution brackets. Simple enough, right? Let's do another one. Now, this is an example. I did one very similar to it on the last one, but we're going to do it again. Because of its simplicity, I believe, it confuses a lot of people. If you look at it, it's the same setup of the last problem. I think just because this one is y equals x drives some kids nuts. So again, looking for that point of intersection, looking for when the x's and the y's have the exact same value. So we're going to use substitution. This y equals this x. This y equals this 2x plus 4. So if we're looking for when those y's are equal, that means that what they are equal to will also be equal. So we're going to substitute that x in for y. Keep in mind y equals x. They're the same thing. They're interchangeable. So x goes in for this y. That equals 2x plus 4. And now we'll solve. This is the old scary situation. So I take a look at it. I got x's on both sides. Keep in mind this guy has a coefficient of 1. So I'm going to choose the side with the least amount of x's. In this case, it is 1x. We're going to subtract 1x from both sides. Now, here's the scary situation we all hate. What's 1x minus 1x? 0. Remember, we're not afraid of 0. 0 equals 1x plus 4. Now it's simple enough. Get rid of that plus 4. We're going to subtract 4 from both sides. 0 minus 4, of course, is negative 4. And that's going to equal 1x. 4's cancel out. And of course, coefficient of 1, we can divide by 1, but no need. Let's just get rid of it. So an x value of negative 4. Now, once we have our x value, we're going to simply go back up to one of our equations, plug it in, solve for our y. In this case, since y equals x, that one's super simple. If y equals x, and we know x is negative 4, y equals negative 4, man. So that means that my solution is the coordinate negative 4, negative 4. Since it's a solution, put it in our brackets, call it done. Remember, if you want to check, if you're like, I don't know if this is 100% correct, simply take those two solutions. Since we used the y equals x to find y, go back up to this guy and put it in. If you notice, if I put a negative 4 in for y, I would have negative 4 here. If I put a negative 4 in for x, 2 times negative 4 is negative 8, plus 4 is negative 4. So negative 4 would equal negative 4. So we can check our answers. Let's do another. Now, this one, slightly different look to it. So we have y equals x plus 4. We have 4x plus 3y equals negative 2. Now, in this situation, there's really only one way we can approach it. Let me try another color here, see if this red will work. So, in this situation, I have y equals x plus 4. The other one is not set equal to a variable. It's not a problem, though. Again, we know that this y equals x plus 4. We know that this y should have the same value at their point of intersection. So what I'm going to do is I'm going to take that x plus 4, I'm going to put it in there for y. One small caveat, though. Keep in mind, this y is being multiplied by 3. That means if we substitute that x plus 4 in there for that y, we've got to make sure everything that gets put in there gets multiplied by that 3, which means we're going to have to use a set of parentheses. So I'm going to have 4x plus 3. Instead of y, I am replacing it with that x plus 4. And that's going to equal that negative 2. Remember, we're replacing or substituting that y with what this one equaled. Now I can solve. 4x plus, since that 3 is in front of that set of parentheses, distribution time, that becomes 3x plus 12, and that's going to equal negative 2. So now we have our variables on one side, but we have more than one set, so we're going to have to go ahead and combine some like terms here. 4x plus 3x, of course, is going to give us 7x plus 12 equals negative 2. Now it's a two-stepper, and I'm running out of room here, so I'm not going to show my steps just because my board's a little too small. So we are going to go ahead and subtract 12 from both sides. That's going to give me 7x when I subtract, I guess I can squeeze it in there. I don't know if you can see that, guys. But negative 2 minus 12 is negative 14. And then I'm going to divide both sides by 7. I'm going to get x equals negative 2. Once I have my x value, I can go back up to either one, plug it in, and solve for y. I think we'd all agree that that top one's a lot easier to work with. So I'm going to take that, y equals x plus 4. I'm going to take my x value of negative 2. I'm going to substitute it in there. And of course, simple addition right there. Negative 2 plus 4, that's just 2. So with an x value of negative 2, y value of positive 2, that's my coordinate. That's the solution to this system. We can verify that by putting that in for x and y here. Make sure it works. And if it does, we're good to go. One more. Then we're going to have you try something. Keep in mind, if I'm moving too fast at any time, you can pause the video. I would assume you guys know that, but you can pause it as we go. So, last one before you try one. Y equals x minus 5. Then we have 5x plus 4y equals 7. That one, of course, is a lot like the last one. So, again, we're looking for that point of intersection. That means the y's and the x's have the same value. This guy says that y equals x minus 5. If I'm looking for the point where these y's have the same value, I can replace that y with what this one equals. So I'm going to have 5x plus 4. Since I'm replacing y with the x minus 5 and it has to be multiplied by the 4, I need my set of parentheses. Now we can go ahead and solve. 5x plus, distribute that 4 into that. That's going to be 4x minus 20 equals 7. So now we can go ahead and solve that. Since we have multiple x's on that left-hand side, we're going to gather up some like terms. This 5x and that 4x are going to combine up. That's going to give me 9x minus 20 equals 7. That's a two-step equation. Should be simple enough. Again, running a little low in room, so I'm going to not show my steps, or else I'm going to put them in here really small. But we're obviously going to add 20 to both sides. That's going to give me 9x equals 27. We're then going to divide both sides by 9. Hope you can see that. I know that's awfully small. And x is going to equal 3. Again, we got an x value. We're going to plug it back in. We're going to get a y value. I assume we would all agree that this top one is a lot easier to work with. So we have y equals x minus 5. We're now going to go ahead and take that x equals 3. We're going to plug it in there. So if y equals 3 minus 5, and of course, 3 minus 5 is negative 2. That means that my point of intersection is 3, negative 2. That is the solution to the system. So we need a set of brackets. Now it's your turn. Again, if you do not have paper and a pencil with you, now would be the time to get it. So you can go ahead and pause this video after I put this system up. Grab your paper and pencil and go ahead and solve it. So y equals negative 4x plus 2. Then we have 2x minus 7y equals negative 14. So what I want you to do is I want you to jot that down. I would like you to jot it down, solve it, pause the video, see what you get, then compare it to what I'm going to get. So pause that video, do it. Okay, now that you have it done, let's go ahead and do it. So, once again, substitution. We know that this y equals this negative 4x plus 2. We're looking for the point of intersection, which means this y and this y have the same value. So we're going to go ahead, substitute that thing in there. So we have 2x minus 7. We're replacing y with negative 4x plus 2. And that equals negative 14. Again, I hope a lot of you remember that since I have this minus 7 in front of what I'm distributing, that's got to follow with it. So I've always told you guys make that plus a negative before you do your distribution. That way you don't mess up a sign. So we have 2x, negative 7 times negative 4x would be positive 28x. And that negative 7 also has to hit that positive 2, which is negative 14. And that's going to equal negative 14. So now we're going to go ahead, solve. Like terms, got to gather them up. 2x and 28x, 30x, minus 14 equals negative 14. At this point, we're going to solve that by adding 14 to both sides. And that dreaded thing's going to happen again. We're going to add 14. Hopefully I can fit this all in. We've got 30x here. 14's cancel out, and guess what? Did that on the other side as well. That, of course, gives you 0. Don't be afraid of 0. So, of course, we would then divide both sides by 30, and we got an x value of 0. At this point, plug that back in, find your y. I'm assuming we all use the top one. It's the easier one. So y equals negative 4x plus 2. We know that x is 0. So y equals negative 4 times 0 plus 2. That's simple enough. Negative 4 times 0 is 0, plus 2 is 2. So now, solution set. 0, 2 is my point of intersection. That's my solution to the system. Did you get that? Good. Let's do one more. One more. Make sure you got it. So last one, we're going to do y equals 3x minus 8 and y equals x minus 12. Write that down in your paper, pause the video, solve it, come back, compare what you got with what I get. Go ahead and do it. Go ahead and do it. Okay, so here we go. This one, set up where they're both in slope-intercept form. So this y equals 3x minus 8. We're looking for the point of intersection, which means this y and this I would have the same value. So we're going to replace that y with what that one equaled. Or you can think of it vice versa, you get the same result. 3x minus 8 is going to go in here for that y. And that's going to be equal to x minus 12. Keep in mind, that x has a coefficient of 1. Variables on both sides. Choose the side with the least amount. Get rid of it. 1x is the smallest one. So we're going to subtract 1x from both sides. 3x minus 1x is 2x minus 8. 1x cancels out. Equals negative 12. Two-stepper you can turn and burn on. Let's add 8. Add 8. 2x is going to equal negative 4. Last step's to divide by 2. I'm going to squeeze it in here. And we wind up with x equals negative 2. So of course, to find y, we plug it back into one of those equations. I think this one's the easier one, this one. So let's go ahead and take that. Y equals x minus 12. I'm going to put that negative 2 in there. So y equals negative 2 minus 12. Negative 2 minus 12, of course, is negative 14. Point of intersection. Negative 2, negative 14. That's my solution set. That's my answer. Did you get that? I hope so. Good. All right, so here's the deal. You have on Canvas, and I gave you a hard copy, you have the worksheets. So find that objective 2, solving by substitution, do the problems. On Canvas below, you'll see the key to the worksheets. Check your answers. If there's anything you didn't get, retry it. If you still don't understand it, you don't know how you got it, shoot me an email. We'll put a video with some problems together and post it up for you. Make sure we're all comfortable before we move on to elimination. Hope it went well for you. See you guys soon.